Hey guys, so I wanted to go over how I got the questions for this Delta Math assignment, and I wanted to go over how to navigate IXL. So for our class, we're in the ninth grade, and we're basically learning a lot of Algebra 1, so the chances that you'll find what we're learning in the Algebra 1 section on IXL is likely. Our unit is on linear and exponential functions. So if you look right here, IXL has a unit on functions, linear, quadratic, and exponential. We'll be focusing mainly on linear and exponential functions in Math 1, and you'll get more into quadratic functions next year in Math 2. So this whole section is basically what we will be focusing on. So this would be a great tool and resource for you to use to kind of get ahead. Their unit T on linear functions is a lot of what we did as a review, right? Finding the slope from a graph, finding the slope from 2 points. So if you struggled with any of these concepts as we did them, I would definitely use IXL as a resource because you can always practice and practice and practice, right? So this would be a great tool and resource. If you hover over any of the problems, you will see that they'll give you several examples. So for example, this one on identifying linear and exponential functions from a graph, that one was exponential, that one was linear, that one's exponential, and that one is linear. So it gives you 4 different preview examples. So you can make sure that before you click on the link that the problem you're doing is aligned with what we're doing in class or with what you want to learn. So we are here on identifying linear and exponential functions from tables. So the first thing that I'm going to do is I'm going to click on this button that says learn with an example at the top. And I'm going to go through and see how this works, right? So here's an example problem. Here's the key idea. And the key idea for this is that you can determine if a function is linear or exponential by looking at patterns of y values, keyword y values. And then they show you the solution. So basically, the difference between a linear and exponential function is that linear functions are repeated addition or subtraction, because addition can always be written as adding a negative number. And exponential functions are repeated multiplication or division, usually always multiplication, because division problems can be written as multiplying by the reciprocal of your multiplier, right? So in this case, because we are multiplying by 2, multiplying by 2, multiplying by 2, each time we're multiplying by the same number, this table represents an exponential function because it's repeated multiplication. And remember that exponents are repeated multiplication. And first they tried to see if it was repeated addition, and since it wasn't linear, because it wasn't repeated addition in the y column, they tried repeated multiplication and that worked. So they knew it was exponential. I'm going to go ahead and refresh this page and look at another example. So learn from an example again. And we're looking at this one. So this one, again, it looks like repeated multiplication, right? So again, they tried to see if it was repeated addition. It wasn't. So they tried repeated multiplication and that worked. So this one would be exponential. So let's take a look at the practice problem. So the first thing, again, just like they did, is you want to look to see if this is repeated addition. So to go from negative 33 to negative 27, you can imagine your number line. If this is negative 33, this would be negative 32, negative 31, negative 30, negative 29, negative 28, negative 27, right? So you would be, if this was addition, you would be going 1, 2, 3, 4, 5, 6 bunny hops to the right. So this would be like adding 6, right? And if we went, well, negative 27, negative 26, negative 25, negative 24, negative 23, negative 22, negative 21 on our number line here, if we extended it, right? That's 1, 2, 3, 4, 5, 6 bunny hops again. So that would be another plus 6. And if you continue that pattern, you see to get from negative 21 to negative 15, you're adding 6 again, and you're adding 6 again. So this is repeated addition. So this is going to be a linear function. The other thing it's asking is this increasing or decreasing? Well, if we're going from negative 33 to negative 9, which would be all the way over here, we're going to the right on our number line. So that means we're increasing. Our numbers are getting bigger they're getting less negative, right? So this is a linear function because it's repeated addition, and it's increasing because our y values are increasing. Let's take a look at another example. All right, so to get from 52 to 44, 6, 8. Okay, so that means you would be subtracting 6. 52, you always want to try addition or subtracting first. So obviously you're going down, so it's going to be subtracting. Minus, let's always write this as addition. So plus, what did I say? 8 minus 8, right, is equal to 44. So this is plus negative 8 or minus 8. To get from 44 to 36, can we do the same thing? Can we repeat that pattern? Well, 44 plus negative 8, and you can do this in your calculator or however you want to, right? I can just imagine that to get from 44 to 40, I have to subtract 4. And then if I subtract another 4, I would be at 36. So I know that that is minus 8 again. So that plus negative 8. So I see repeated addition happening, right? Plus negative 8 again. So this is going to be linear. Now I'm going to look at my y values and ask myself, are these increasing or decreasing? Well, as my x values increase, my y values are decreasing, right? From 52 to 20, we're decreasing. So this would be a decreasing linear function. Another one here. And one of the things that you can look at also is we know that exponential functions get bigger faster. If you think about the Genie project that we did, the difference between option B, getting 5,000 coins a day, or getting one magic coin that doubled every day, those exponential problems get a lot bigger, a lot faster because exponents get bigger faster than multiplication, or repeated multiplication gets a lot bigger faster than repeated addition, right? So I'm going from negative 31 to negative 63. That's not a huge difference, right? So I'm guessing my hypothesis is that this is linear. Okay, and we're going to check, but I think that it's going to be linear. So to get from negative 31 to negative 39, the first thing I'm going to try is to see if I have repeated multiplication. So this is subtracting 8 or adding negative 8. And this is adding negative 8 again, minus 8. This is adding negative 8 again. So this is repeated addition, right? Because we can think of this as adding negative 8. So this is going to be linear. I was right. And we're looking to see, are we increasing or decreasing? When we're starting at negative 31 at our number line, negative 31 would be here. Negative 63 would be all the way over here, right? So we are going to the left, we're decreasing. So this would be a decreasing linear function. Oh my, I think this is the same thing. Is this decreasing? Well, obviously it's decreasing. But to get from, this would be minus 6, minus 6, minus 6, minus 6. So this is a decreasing linear function. Your y values are decreasing, and you're decreasing by the same amount each time. You're subtracting the same amount each time. Let's get a good one. Here we go. So to get from 5 to 15, we can add 10. To get from 15 to 45, we would add 30. So already we're not adding or subtracting by the same number. So this is not linear. So let's test to see if this is exponential. To get from 5 to 15 using multiplication, we could multiply by 3. To get from 15 to 45, we could multiply by 3. Multiply by 3, right? So this is exponential. It's increasing because my y values are increasing. And if you notice in the y corner, in the y column, you go from 5 to a triple digit number. You go from 5 to 405 really quickly, right? So if I were to hypothesize early on, I would have assumed that this was exponential because of how quickly it got really big. It went from a 1-digit number to a 3-digit number. So I would think that that's exponential. Let's do a couple more. So this one, we went from a 1-digit number to a 2-digit number. Not the biggest difference, but still pretty big. So I'm gonna hypothesize exponential. So you can just test your hypothesis. You don't always have to try adding, right? If you think it's exponential, see if exponential works, right? So here to get from 4 to 8, if it is an exponential problem, we'd be multiplying. So that'd be times 2. We could do times 2. We could do times 2. So yeah, we were right, right? Repeated multiplication, we are multiplying by 2 each time. Another one-digit number to a 3-digit number, I'm going to think exponential, right? I think this is going to be exponential. So let's test my hypothesis. To get from 2 to 6, that's times 3. To get from 6 to 18, we can multiply by 3 again. And to get from 18 to 54, we can multiply by 3 again. So yeah, my hypothesis works. And this is exponential, and it's increasing because we went from 2 to 162 in the Y column. Oops. Let me click on it. Oh my God, you're lying.